Hi everyone, thanks for coming. My name's Neil Perry, and today we'll be looking at an introduction to Backup Assist. Just before I begin, if you haven't already, please click on the Q&A session button, bottom left. From there, you can ask any questions that you might have as we go through the webinar. Hopefully, there'll be some time at the end as well to ask and answer any more specific questions you might have. But without further ado, let's begin. Just before I start, I just want to sort of give you a little bit of background about the developers of Backup Assist. They're actually an Australian company called Cortex, and their focus has always been to design software for small to medium-sized businesses. Initially, Backup Assist started out as a front-end tool for NT backup. It's grown beyond that now to offer a wide range of different backup technologies under one roof. They're very much focusing on existing technology types, and they integrate with third-party technologies that I'll run through as we go along to create a layered backup strategy. Often with backups, it's always a good idea to not just rely on one sort of backup, but to provide different mechanisms that work best together to allow you to restore in different scenarios. Everything from bare metal recovery right through to individual files or mail items. And one of the things that we like to do as the as the distributor of the software is to provide you with that sort of excellent support. We're a very technically led company, and we like to sort of make sure that we're your first line for looking into how to use the software, but also how to integrate it with other technologies and provide first line support. Support is free with all our products when you purchase it with upgrade protection. So I just wanted to start by looking at some of the key selling points in Backup Assist. One of the first things we get a lot of feedback about is the actual interface and the easy-to-use interface. It's very much a wizard-driven technology. You create jobs, you run through the individual wizards for the different style jobs, and by adding multiple jobs and scheduling those jobs at different times, you can even have some jobs setting up other jobs, etc. You build this layered backup strategy. The jobs themselves have built-in media rotation options. In the upcoming release, which is due quite soon, there is also a custom scheme that you can select to be more specific about when you rotate, whether it's tape devices, USB hard drives, RDX drives, anything where you've got multiple media and the managing of those multiple media devices. Now, like I say, they're predefined schemes, but there is this ability coming up to customize those schemes. Backup also takes care of reminding users of when those media devices need to potentially be changed. You can customize the messages that are sent out. You can send out different messages to different team members. This is just the alerting. There is a whole section as well about reporting for when a job has run and how successful it was, which components may or may not have run on that particular time. You get a full breakdown of the job itself. It's not just a success or failure, it's a full breakdown of what happened throughout the job. The media usage report is part of that email report as well, and that gives you a clear understanding of what the destination media contains, how much data was used up for each backup, how well the compression algorithms have been working, how many backups it contains, and how full the overall drive is. So it gives you a good idea of how successful your backups are. Of course, along with backup, restoration is also very important, and Backup Assist includes the Backup Assist Restore console, and that is your gateway to restore any files and folders from any of the backup jobs that are created. So you can drill down into one or multiple backup jobs looking for old missing files, for example, or you can select a particular job or search for specific files and find them across multiple jobs. It's a very easy to use application, but it's key to being able to restore data, and users don't have to learn different mechanisms for different backup types. Encryption forms a good part in Backup Assist. There are different encryption technologies throughout Backup Assist, and I'll touch on them as we go along. But just to give you an idea, there we've got TrueCrypt encryption for the file protection-based jobs. rsync itself is something we'll look at in a lot of depth later on, and that has its own encryption module for encrypting files before they're sent off-site. And the zip archiving jobs as well; those also deploy encryption built into the backup, the zip backup on tape media or other destinations if you're choosing those. There are effectively multiple different protection types. I'll walk through these individually in a moment, but generally they're categorized into system protection, so we're talking about bare metal backup, but that can also be used for backing up individual drives or even files and folders or even applications. So even though system protection is very much what you would use for a bare metal backup, it's not its only role. Then we've got the file protection job, which is your traditional files and folder backup. That can also include applications, so running applications. All of the backup technologies within Backup Assist are open file aware. They link in with Microsoft VSS service. So even though we're backing up files and folders, we can back up, running applications, Exchange, and SQL Server that are local to the machine. File archiving is really for off-siting for long-term archiving of files, but it's also the main component that provides tape support within Backup Assist. So we'll look at that near the end as well, just to show you how that is different to file protection. Then there are two other plugins for Backup Assist for Exchange mailbox protection, and that's the need to take a granular backup or restore of mailbox data. There's nothing stopping you backing up an Exchange server, the whole Exchange database with, let's say, a system protection job, but from there you could only restore the whole Exchange database. If you want that ability to drill down further into the Exchange backup, then we're looking at the mailbox protection component. Then finally, the SQL Server protection is an additional add-on that provides the ability to back up local and remote SQL servers in a more granular way. So again, we'll take a bit more of an in-depth look at that. So I'll start with system protection. So like I said before, system protection is really about bare metal, but we're not just limited to taking a full backup of the whole physical server. It's based on the Windows Imaging Engine, so WBadmin, and therefore it can provide the ability to do differential updates of those backups. Now that does depend on the destination media. Out of the box, you can back up to local USB hard drives. In fact, I think that's on the next slide. USB hard drives, local internal drives, iSCSI targets. Those all out of the box support differential updating. If you want to support the ability to update your backup, so what I mean by that is you're not taking a full snapshot of the drive every time, taking up a lot of space and the time it takes to do a full snapshot. After that first backup with a differential update, the data is updated, but the previous snapshot of that backup is taken, so you have the ability to go back to a previous backup over time. So differential updating is great because it's a much quicker way of updating your backup, and it gives you a lot better use of space in the backup media. For local drive destinations, that's supported natively. For network shares and also for RDX cartridges, you can still support differential updating with Backup Assist. It actually uses a VHD container to just kind of trick the system into believing that it's a local destination. So that allows you, in essence, to push multiple backups from different servers all to, say, a network share, but still get all of the benefits of differential updating. So because of that differential updating, the system protection jobs are the most efficient within Backup Assist. They're disk block level, they're not files and folder backups, so the actual access to the data is quicker. Writing the data to the backup media is generally the quickest, and also because you're only updating that data after the first backup, then the actual process of running the backup that second time and onwards is much, much quicker and storing much less space. System protection is obviously VSS aware, so you can back up protected files, system applications, files and folders, everything on the drive. There's no worry about not being able to back up something because it's in use. You certainly don't have to start and stop services, which you sometimes have to do in older backup technologies. You can see there, just as a quick example, on the left-hand side, that's what I'm choosing the files to back up or the drives to back up. You can see the difference between at the top, you've got your critical volumes. Those needed to do a bare metal backup. Then you've got any other volumes that may well be on the drive, and then finally you've got any VSS-aware applications. This example is a Hyper-V server, but if it was, say, an SBS server, you may well have an Exchange element there and an SQL server element. Any applications that are VSS-aware and have VSS writers will show up separately. So if I wanted to, I could do a system protection job that only included my Exchange server. So it would be a much smaller backup, but it would have all the benefits of incremental updating. It's very good at taking a backup of a large file like an Exchange server database. The VHD container option is there, like I say, to allow you to support differential updating on a network share and an RDX drive. When you're running through the wizard, it's this option at the bottom to enable data container. So all it's really asking you for is the path. In this example, it's a network location. So the path to create this container. User credentials to access that path. It may well be that you need credentials on a NAS device or a Windows Share, and then you define the size of that container. So think of this as a virtual backup device. If you were to back up to a USB hard drive, what size drive would you be using? This is quite a small backup, so the destination we've chosen, 300 gigabytes, is quite reasonable. The rule of thumb is the destination for an system protection job should be 2.5 times the source data. So with a drive of 300 gigabytes, I'm looking at backing up a server of around sort of 70, 80 gigabytes. That's the sort of size I'm talking about. It may well be that you need to create a container that's bigger than that. The limit is 2 terabytes for a single VHD container. If you need more than that, it may be that you have to split your backup job into multiple jobs. Like I said before, there's no limit to the number of jobs you create in backup assist, so it's not unusual to create separate jobs backing up separate parts of the data. Recover Assist is the tool that is used to actually recover any bare metal backups you've created. So with that bare metal backup, if you went to a new hardware, whether it's the same hardware or different hardware, you need to boot from a media to restore from. And within Backup Assist, when you create a job, when you create a system protection job, the final step is to create the Recover Assist boot media. There's two options here: whether to create it from the installed version of Windows. It's using the Windows components to create a customized Windows boot environment. So you can create that from the installed version of Windows, or you can point it to a Windows boot disk. That's quite handy if you want to create Recover Assist in the future. Let's say you need to create it for a Windows 2012 server, but you're actually running Windows 8 on your own machine. There's nothing stopping you run up Backup Assist on your own machine, run through the process and pointing it to the 2012 server 2012 boot media. So it just gives you the flexibility to create a Recover Assist boot media for a different operating system. You will need a Recover Assist boot media for the operating system that the backup is of. It's the same version. So 2008 R2 is different to 2012, is different to Windows 8, etc. But within those categories, you don't have to have every single release. When you actually boot up Recover Assist, you've got a few more options over the standard Windows boot media. You can restore from local drives and externally attached drives, but things that are physically local to the machine. But you can also restore from network shares. You can restore directly from iSCSI targets. You can even mount VHD containers, which can be useful in certain scenarios. If you've backed up to a network share within a VHD container, let's say, you can connect to the network share and mount the VHD container to restore directly from it. So you've got a few more different options for where you can restore from. And all the local media as well, RDX drives are quite common and fully supported. There's also a couple of tools there to allow you to help you repair a potential Windows installation that's blue screening, and also a command line tool set that you can drop out to. I haven't shown you here, but when you create the Recover Assist boot media, there is the ability to add custom applications and drivers as well. And it's all trying to create a boot media that's ideally suited to allow you to quickly restore your particular hardware. So if you know that in the future you're potentially going to need specific drivers, you can add them to the boot media, so you're not having to rush around and find those drivers when you're potentially trying to quickly restore a machine. I want to touch on Hyper-V backup at this stage because it's very much tied into the system protection jobs. So up to now, I'm really thinking about a standalone server. But if that server's running Hyper-V, once you've taken well, I should say, if you've installed Backup Assist on the physical server and only on the physical server, from that image backup, that system protection backup of the Hyper-V host, you can do several things. You can restore the whole, you could do a whole bare metal backup and a bare metal restore the whole Hyper-V server, so that would include all of your VMs potentially. Or you can drill down into that backup and choose one of the VMs and restore just the VHD files associated to that VM. So if you potentially wanted to turn up a VM back in time, you could do that, or you could restore that VM to a different Hyper-V server if you wanted to. It's one method of migrating a server, or duplicating a virtual machine, I should say. But you can also go down further. You can drill down into the backup, further into the VM, choose the actual drives that were backed up at that point in time, and mount those drives on the host as a virtual hard drive. So you can effectively see the file system of any of the VMs at a point in time. So if those are, say, VM2 contained files and folders that a user had accidentally deleted, a week later they realize they've deleted them, you could go back to your system backup, drill back in time to a week ago, choose the VM, open the file system, find the files, and then restore them directly back into the VM. Generally speaking, that would be through a network share, a virtual network share, but it's all accessible through that one backup. So it's a very flexible way of making use of the system protection job. You've got nice, quick backups taking place. They're updating with differential update support, yet you can still use them to do not just bare metal. You can really drill down to particular files and folders. Because the backups the differential backups are quick, it's not unusual to run backups throughout the day. It's not necessarily just a single backup a day, and this is quite key with Hyper-V, where you potentially have servers changing quite a lot throughout the day. You may find that you're running it 3, 4, 5 times a day, and that allows you to go back to snapshots of these VMs, for many days, maybe even weeks back in time, but not just once a day, to particular hours in the day. I'll move on a little bit now to talk more specifically about the file protection jobs. Now, file protection is your more conventional style backups, where we're talking about files and folders, but we are still including here applications, running applications. Supported destinations, external drives, USB hard drives, eSATA, RDX drives are very popular. It's not quite as efficient as system protection, but it does have the added benefit of storing files and folders natively if required. You can back up to local directories on the server if you need to, or network locations, and also it can directly talk to iSCSI targets, which is also a very popular destination. It's probably the quickest way of getting a network backup, or I should say a backup to a network destination. And then finally, rsync is a technology for off-siting of file backups over low bandwidth connections. This falls under the file protection section as well. File protection is the main component that manages the media rotation. So if you're looking at those conventional backups where potentially you've got a pool of, let's say, 7 hard drives, USB hard drives you're backing up to, and you want a Monday through to Friday backup drive and a weekend backup drive, or you may have monthlies or quarterlies or yearly backups, that technology is all managed through file protection. Encryption is handled through TrueCrypt encryption, and that will allow you to create an encrypted volume on the destination and back up to that volume. Both encrypted and unencrypted backups fully support single instance store, and this is a technology that allows you to effectively get more use out of that destination. It's not traditional compression. You're not compressing each file. In effect, what you're doing is choosing to only back up a file on the destination if it's changed. If that file already exists on the destination because it was backed up previously, then create a pointer, a file pointer to a single instance copy of that file hidden on the backup media. So even though when you look at the backup media it looks to contain lots of full backups, in reality you're only storing the space required for one full backup and all the differences every day. There are a variety of backup schemes that you can choose from, and like I said before, there's a custom scheme on the way as well to be even more flexible. So I just wanted to explain in a little bit more depth the different types of backup jobs in file protection. So there's two main types. The first one is mirroring, and this is really only used in one scenario, but I thought I'd mention it anyway. When potentially you want to mirror a file system to a single remote destination. So every time this job runs, it looks at what files have changed in a very large folder structure and updates the remote destination. There's no history kept. If a file gets deleted, it gets deleted on the destination, but you don't have that in the future. So it's ideal when you want to have a mirror of a file system that may well either be backed up itself through another mechanism, or we often use it for a standby server scenario where you want to have like our MDaemon server. We often mirror to an additional VM as a sort of a single daily job. So you just know that you have a snapshot of the file system ready as a sort of template to restore even finer grade changes to. Most of the time with file protection, people are doing backup jobs with history. But in essence, that is still a series of mirrors. Every time the job runs, it's mirroring the source data and storing it within a destination folder. It depends on the scheme you choose exactly the naming format of those folders, but typically it's the date that the backup was run. So here you can see, as a typical example, I've got two destination drives shown for Monday and Tuesday. For Monday, the Monday folders, the dates for those Mondays are kept, and then for Tuesday, the backup is kept in the Tuesday drive for the dates for those Tuesdays. Each one looks like a full backup, and this is the important thing about file protection. Even though you're only pushing files that have changed, if you went into Windows and you opened up these files and folders and drilled down into them, they would look to contain all of the files and folders that were backed up, a full backup. You right-click on the properties and it shows you the size. But in reality, you're only storing the data that's changed. Like I mentioned, there's many different media rotation strategies. You can even customize this further by having multiple jobs. I often get asked, for rotation schemes that are quite unique. People say things like, well, I'd like a backup that runs Mondays and Wednesdays and a different drive for Tuesdays and Fridays. And you get these strange sort of schemes. Well, you can manage that by having a job for each set. Have a job that only runs on Mondays and Wednesdays. Have a different job that's, in all intents and purposes, identical. You can even clone a job, but change the day so that only runs on Tuesdays and Thursdays. You can change this around to really match the rotation strategy that you're used to. I said before that all open files are supported, so here's a nice screenshot that gives you an idea of what you would expect to see on a typical SBS type server, where you've got applications are showing up underneath the drive. So even though I know that my SQL Server database exists on my C drive in a particular folder, if I just select SQL Server as an application, everything that's related to SQL Server will be backed up with that job. So it's a very nice, tidy way of selecting applications, but it also means that Backup Assist is talking through to Microsoft VSS through the relevant VSS writer to instruct to that application that it's about to be backed up, and make sure that that you get a consistent backup. Data isn't changing whilst the backup is taking place. I've kind of covered this already, but I just want to show you an example of how single instance store is showing the data, because often I speak to people and they don't really realize how it's working. typically you will see a compression ratio of about 10:1. It does differ between different data sets, but what I mean by that is, well, in this example, let's take this example. This is a roughly 200 gigabyte USB hard drive, so it's not very large, but you can see that the total of those backups, if I go into Windows and I look at what's on that backup drive and I add up all of the drives, it's actually totaling 2 terabytes of data. And that's because across those backups, there's a lot of files that haven't changed, and every time a file hasn't changed, it doesn't need to update the data. So in essence, even though they look like files, they're actually pointing to the same disk sectors on that destination, and therefore Windows is counting those files multiple times. So in essence, you get about 10:1 compression ratio, and it means that you can get days, if not weeks, of backups on a media where you typically maybe only expect to get a week's worth. So if you do that across, let's say, 7 USB hard drives and you're rotating those, you potentially have got weeks and weeks of history of daily snapshots. So it's a very nice way of making sure you've got a lot of history there, and it's nice in the sense that you can get easy access to that. You can use the recovery console to get access to the data, but easily you can also open this drive directly. Obviously, the flip side of the openness of a standard file protection job is that you can get access to that data, and that's why TrueCrypt encryption has been added. That is turned on at the point of setting up the job. So instead of writing directly to the destination drive, you actually create an encrypted container. You choose again a volume size, you choose a strong password and confirm that password. But from that moment on, it's mounting an encrypted volume, and then the backup is effectively to the drive letter of that encrypted volume. Often, if you're using Backup Assist, you'll see in the logs it mentions typically a Z or a Y drive. Well, that's the temporary encrypted volume that you're backing up to. So that means that when you take that drive outside of your network and you plug it into another machine, all you're seeing is an encrypted volume file. You need the password to get access to that data. It's not just for USB drives. It will work on any destination, any hard drive destination, RDX drive, network share. You can deploy it in different scenarios as well. Oh, that's just a quick screenshot there showing you what would exist on the drive. One of the things that I like to do is there is an option as well to choose to include the TrueCrypt binaries on the destination. And that just means that when you take that USB drive, backup drive to another destination, another machine, you can actually mount the volume, and as long as you have the password, which is the key important bit, you can mount the volume and get access to the backups. TrueCrypt uses AES-256-bit encryption technology. It does automatically mount and dismount the backup when the job runs. So, from Backup Assist point of view, it's doing that in the background. It still supports single instance store. So you still get all the benefits of the compression. Effectively, it's not compression, but the equivalent of compression on the backup destination. When you want to restore data and through the recovery console, you can it automatically decrypts the data. It will pop up and ask you for the password. Whenever you do any restores that are encrypted, you need the password. But it manages the whole process of mounting the destination and getting access to the actual files within it. So moving on slightly, often I get asked about rsync in Backup Assist, and rsync is probably one component that brings a lot of people to Backup Assist because they want an ability to take backups off-site of large volumes of files and folders. So the reason rsync exists is that typically, historically, you would use FTP as a method of pushing files over the internet to remote servers. But FTP is very inefficient. It not only has to copy a file in its entirety if it's changed, which is inefficient in itself, but it often actually sends more bits and bytes for that file just to push it to the remote server than the actual file is created. So For anything other than relatively small backups, FTP is not efficient at all. rsync as a technology is designed to manage the bandwidth in a much more efficient way. The difference is that it's actually monitoring files for block level changes. Let's take an example. If a large Word document changes by a few characters, that one file may be 10 megabytes in size. It's quite a small file, but if only 2 or 3 characters have changed, you don't want to have to send the whole 10 megabytes every time. You add that across thousands and thousands of files, and the saving is massive. rsync will look at the file, see which parts of the files have changed, send those parts across to the remote rsync server. Backup Assist is an rsync client in this model, so it sends the parts, the delta changes across to the rsync server, and the rsync server then reconstructs a new version of that file based on the previous backup that it has and the changes. So the actual traffic between the client and the server is very low. Not only is it only sending parts of the file, it actually compresses that stream of data in transit as well, and typically gets a 2-to-1 compression on top of that as well. What that means in reality is after that first backup, and I'll explain that a little bit more in a moment, after that first backup, the ability to update a large folder structure of file and folder structure, many thousands of files, is very quick. It analyzes to say which files have changed, which bits of those files have changed. Okay, here's a list of bits that I need to send those across, and the rsync server then reconstructs those bits. Just like the other backup jobs, it can support a mirror style backup, so it just updates the destination every time, and it's just overwriting it, or it can store backups with history, so you can have a rotating week of backups, or weekly and monthlies if you want, or daily, weekly and monthlies. You've got different schemes to choose from, but in exactly the same way if you were using local drives, you can store history, and it manages those backups for you automatically. And open files are fully supported. However, just bear in mind, with very large files, things like Exchange databases typically, the time it would take to analyze a very large file, tens of gigabyte file, it's going to take time to look to see what files have changed, or what blocks have changed. The actual process of pushing those blocks off site might not take very long, might be quite quick. But then again, at the rsync server, it has to reconstruct that file. So even though with very large files it's still very bandwidth efficient, there is this time element, and that means it's not ideally suited for single large files like Exchange server databases, like VHD files for virtual machines. rsync is ideal when you're backing up a large number of smaller files, sub 1 gigabyte files, that sort of size of data. The initial backup is always the sort of worry with rsync, is how do I get all my data to that remote rsync server that first time? If you sent it over the internet, that is one option. Then you've got to send every bit of every file, so therefore everything's changed. So it will still do that compression, so it's possibly about half of the data that needs to be moved, but that's still a lot of data. So to get around that, you can seed that data, and there's a function within Backup Assist to seed that data to a local removable media like a USB drive, physically then take that drive to the rsync server, where you run a script on the drive that will kind of cheat that process and push that data directly to the rsync server as if it was coming in over rsync. It's important to do the seeding process because as part of the moving of the data, it creates the remote delta information, the information that is used to say, well, which bits of these files have I already got? So you can't just copy the data and expect then rsync to know what's on the destination. It has to do it through a seeding method. There is the option to encrypt the rsync connection from client to server, and you can use rsync over SSH to do that. In that scenario, the data is still stored unencrypted on the destination, but it can't be eavesdropped on the actual network on the internet connection. It's encrypted through transit and then decrypted and stored on the rsync server. Up to now, I've been talking about the rsync server. What is the rsync server? Well, in a Backup Assist scenario, Backup Assist is the client. It's pushing data to a remote rsync server. Now, there is a free open source Windows rsync server that Backup Assist have been fully tested with and support, which is called CWRsync server. That's available on the download page if you're looking for where you can get that and how you can set that up. There's information exactly the process in doing that. It's ideal if you're trying to back up to a remote Windows machine and you want to store your backups there. It ties itself into Active Directory as well, which is nice. If you're looking for sort of a standalone solution, then a lot of customers go for NAS devices. Majority of NAS devices themselves have built-in rsync support. Most will have standard rsync. I've not really covered that here. We prefer to use rsync over SSH where possible, and a lot of the rsync NAS devices also support rsync over SSH. Just to throw some names in the pot: Netgear, QNAP, Synology. They're three that we come across time and time again that a lot of customers use. We ourselves don't support any of the hardware directly. We don't sell any hardware, but we obviously, have worked with lots of customers when it comes to setting these up. So, we're more than happy to help where we can to sort that out. The rsync encryption is different to the previous TrueCrypt encryption I mentioned. Unlike TrueCrypt, it's not creating a single standard large file encrypted folder. With rsync encryption, it encrypts every file individually on the server first in a temporary location, and then moves or rsyncs that encrypted version of the file to the remote server. So the process of rsync is identical. It's just the ability to create an encrypted file version first. Therefore, on the destination server, you would see that your backups are stored in the same folder structure. You can kind of see the differences there between that Monday unencrypted backup and the Thursday encrypted backup. You can see the structure's the same, but you lose all the visibility of the folder names, and the file names are obviously encrypted as well, and the data within the file is encrypted. When you use rsync encryption, then you do need to restore through Backup Assist. You've got no direct access to the unencrypted version of that data. You will obviously need the password as well. When you create an rsync job with encryption, you ask for the password to use as the encryption seed. So restoring from rsync jobs, whether encrypted or otherwise, is the same procedure. You log in. Sorry, you start up the Backup Assist restore console, and you can select which backup job, the rsync backup job that you used, the date that you want to restore from, and then you can just look at the file system. Backup Assist creates local catalog files where it stores what's been backed up. So the process of scanning through to see what you want to restore at this stage isn't connected to the backup media, or in this case rsync server. It's only when you actually click the restore button that it goes to the backup media. So it's very quick to find what a backup contained. rsync is quite a popular feature with Backup Assist, so much so that the developers created a standalone license version, and this allows you to use Backup Assist rsync function outside of the main product. You're still installing exactly the same application. It's a full-blown Backup Assist you install, but when you purchase a standalone version, rsync standalone license, it's a cheaper license. The prices are on the website, but it's a cheaper license that allows you to just run rsync jobs. So if you're thinking, oh, I like the features of rsync, but I don't need to do local file-based jobs or local system protection jobs as well, then there is a lower cost solution there. It does include 1 year upgrade protection, and therefore we give our free support on top of that, and it does tie in with the centralized monitoring console, which I'll talk about very briefly at the end. But generally speaking, it's a way of thinking of, it's almost like a smaller client that allows you to do just rsync jobs for maybe multiple machines. We've come across it where people potentially want to do file-based backups of virtual machines. So they may be doing a system protection job of a Hyper-V server, but they also want to offsite files from within the VMs. Where the ideal way of doing that is to install rsync standalone on the VMs and push that data directly to a remote rsync server. I want to talk a little bit about file archiving jobs. Again, this is a file-based backup, but this is very similar to your traditional NT backup type technologies. The main reason that file archiving jobs exist is for one key function that isn't included in any other type of job, and that's to provide tape support in Server 2008 and above. But I'll show you that a little bit later on. Think of file archiving just like NT Backup. It's got the ability to create full backups, incremental style backups, differential style backups. It's just like NT Backup in the sense that you're creating a single file on the destination. In this case, it's a zip file. It uses the zip64 standard compression technology. But it's a single file, and it wraps up all the files that need to be backed up and stores it within that one compressed file. It can manage a pool of media. It's got lots of different schemes for doing that. You can back up to multiple destinations, not just tape, but in all honesty, if you're doing file-based backups to, let's say, USB hard drives, then it's going to be a lot quicker to use a file protection job or even a system protection job than it is to do the same data through file archiving. It's really there for when you specifically need to do tape backups. Backwasys licensed a separate zipped tape function inside a Backup-Sys, but that's what the zip to tape add-on provides. It's the ability to back up zip-based jobs to tape devices. File archiving also supports compression with AES-256-bit again, and it can, encryption with AES-256-bit, and it can also do compression at various levels. However, I personally recommend that if you're backing up to tape devices, not to use the zip compression, but instead allow the tape device to use its own built-in hardware compression. Typically speaking, it's usually slightly more efficient in that it'll be slightly more compressed data, but it is quicker to allow the hard drive to do that compression. The zip compression is really there. It's a historic function that's really there for network shares and local drives. But like I say, people don't tend to do file archiving jobs anymore to those technologies. It can be used for files and folders and VSS-aware applications. Unlike sort of ASIC jobs, local file archiving to tape is quite capable of backing up large files. One thing to bear in mind, though, I'll talk a little bit in a moment about some of the add-ons. When you're backing up to a file archiving job and you're creating a large zip file, to restore that data, you can't mount it live. You can't get direct access to that data. You have to restore the whole file to be able to then access it. So I'll touch on this in a little while, but for Exchange databases, I couldn't, for example, drill down into an Exchange database within a zip file archiving job without restoring that whole Exchange database to a temporary location first. So it's another reason why we tend to only use file archiving when we're talking about large number of smaller files and folders. It's not that it can't back up a very large file, it's just that it's an efficient way of doing it. Occasionally we've come across the scenario where restoring a very large file means restoring the whole zip container first, so it's just worth also bearing that in mind. And that sort of brings me on to the sort of the add-ons within Backup-Sys. I wanted to start with Exchange Mailbox Backup. There are two methods for backing up, or brick level backup for Exchange. The legacy method is the mailbox add-on, which is actually more of an archiving method. It backs up the data within Exchange databases and stores them, the mailbox data, I should say, user mailbox data, in individual PST files. Now, this is a long-standing technology. It requires that you can connect to the Exchange server through a MAPI connection, and it pulls the data out of Exchange and stores PST files. Now, it's ideal if you want a separate archive of all your Exchange data and in PST file format, but it does require an additional job to do that, and it does take extra time to run through and create those PST files. It only supports, this method only supports Exchange Server 2003 up to 2010, which is worth bearing in mind. Because it has to be a separate archive, you have to have a local storage to store those PST files. These type of jobs can store it to a local hard drive or to a network share. It can't store it directly on, let's say, a removable, on like an RDX drive or a tape device. It has to be to local hard drive technology. It's only really a mirror backup. It's designed to update this archive of PST files every time it runs. So if you want to go back in time, then you're expected to back up the PST files again, which adds to your backup size and time as well. And the other sort of thing to bear in mind with the Mailbox add-on is that when you come to restore the data, you can only choose a date range to restore. You can't be more specific than that. For those reasons, a newer technology has been developed, and this is what we recommend with all new Exchange deployments. As long as you're running Exchange 2007 onwards, it's only Exchange 2003 you can't use this method with. Then you can use, with 2007 onwards, you can use the new Exchange Granular Restore add-on, often referred to as the EGR. The beauty of the EGR is there's no need to back up anything else separately. As long as you've already got either a system protection job, a file protection job, or even a file archiving job, it is possible, but generally speaking, we recommend system protection or file protection. As long as you've got one of those jobs that includes your Exchange server, so the Exchange server has been listed as a VSS application, you've selected it to be included in your backup, and in essence you've got a copy of the Exchange database, then you can use the Exchange Granular Restore console to drill down into that backup and get access to the mailboxes that it contains. Therefore, there's no additional time to run a separate job, there's no storage requirement to run a separate job, and you've got all of that history. You can go back in time and say, I want to look at my Exchange server as it was a week ago, 3 weeks ago, a month ago. As long as you've got a backup that included a snapshot of that Exchange database, you can go and mount that Exchange database in a previous version. It's worth bearing in mind that from a licensing point of view, if you purchase the new Exchange Granular Restore console, which is the only product you can now purchase, you're still licensed to use the legacy method to back up to PST file. So we still do have customers that prefer that method, or the specific reasons why they want an archive. We even have some customers that use both. There's nothing stopping you, having the benefits of both. But they've kept that feature because there's still a need, mainly because there are still customers out there with Exchange 2003. And the new method only supports 2007 onwards. So I just wanted to quickly show you the Exchange mailbox protection, the existing method to export to PST, because that's the different backup job, and that's when you look at within Backup Assist and you choose to back up the Exchange mailbox, that's what you're running. Like I said before, if you want to use the newer Exchange Granular Restore console, there is no job to create, so there's no need to add another job here like I'm going to show you. But for those legacy customers, just to explain how it's working, when you take a backup of Exchange through the Exchange Mailbox add-on, you're creating a set of PST files. You typically choose a scheme where you maybe would store those in either monthly, quarterly, or yearly folder structure. That way, you're not going to hit a limit, 2 terabyte limit per mailbox. So you can see here we've got 3 quarters, and the 4 users have a PST file per quarter. Then every time that the backup runs, it's updating, in this scenario, the current quarter's data. But again, you can imagine this is you've got a whole range of PST files, an archive that then is stored locally. So you can get quick access to those to restore data. But you can also, if you need to, then take a secondary backup of those offsite. In Backup Assist, the actual method of connecting to the server, you can connect to a local server, i.e. Exchange running on the machine Backup Assist is running on, or you can point it to a remote server as well, which is another benefit of this method. If you have one or more Exchange servers on the network, you can connect to them and bring in data from those other servers. You choose the actual mailboxes you want to back up, and you can also choose whether to back up public folder data as well. There are different methods for connecting to Exchange. I won't try to cover this in detail now, but generally speaking, depending on whether Exchange is local or not. If it's local, you tend to stick with the default ANSI PST using the Exchange management tools. If it's remote on another server, then you may find it's actually more efficient to use the Unicode PST if you've got a local copy of Outlook running. Like I said, our preferred method is not to use this function, but if you are wanting to connect to a remote server, or you specifically need to create a PST archive, then these are the options that are relevant. When you're coming to actually restore data through the Exchange Mailbox add-on tool, then you can see that your options are to drill down into a backup and choose the Exchange server that was backed up. You can then choose which specific mailbox you're interested in restoring, and you can choose a date range that you want to restore from. So the finest detail you can get to is a particular date. So you can say, well, I want to restore all of Fred's email for Thursday. Then you can restore that data to either the original Exchange server, so push it back to the server it was backed up from, a different Exchange server, or you can write that data out to a PST file specifically that only contains the data you're interested in at a particular path. If you push the data to an Exchange server, you can also choose the mailbox you want to push that data to, so it doesn't have to go back to the existing the mailbox it was backed up from. Looking at the newer function, the Exchange Granular Restore console, which is, in our opinion, definitely an improvement over the PST method, this allows you to drill down into an existing backup that you may have taken, that you will have taken, that may contain an Exchange database. So when you go into the Restore section of Backup Assist and you click on the Exchange Granular Restore console, the first thing it's going to do, after you've selected a date range, so you can say I'm interested in a specific date range or all of my backups or the last 7 days or 30 days. Once you've chosen the date range, it's then going to scan all the backups that you've taken. It's effectively looking inside its catalog files, and it's going to show you which of those backups contain Exchange database files. So you can see here that I've got 2 database files that were backed up on a particular date, and I can then select any EDB file it finds. And I'm effectively mounting that mailbox data at that point in time. And then you get a really nice console. This gives you a view of that whole Exchange database. Doesn't matter if it was backed up on a different machine, you've got full access to the Exchange data. You can see the mailboxes, you can drill down to see the folder structure, you've got access to all other data like calendars and contacts, journal information, everything you would expect to see within Outlook. You can really use it like you would use Outlook to view a mailbox. You can see the actual messages, their subject, who they're from, who they're to, the date and time. So it's very easy to find specific missing messages. So you can select those messages, or you can select whole mailboxes using the ability to multiple select data that you want to restore. There's even a built-in search function that gives you, ability to search for things that are a little bit more specific. Looking for words within the body of the message is very useful if you're not quite sure who sent you that message. Once you've found messages, anything you select then and then you go back to the browse window is part of the data you're about to restore. The options for restoring, you've got 2 options really. You can export into a PST file, so you can just choose data and say, right, write this out to a PST file local to me now on this Backup Assist server, and then you can take that PST file and open it with Outlook or import it back into Exchange if you wanted to. It's kind of long-winded way of doing it. Or you can just store it as a PST file. So it's totally up to you what you want to do with that. The other method is to actually connect to an Exchange mailbox. It doesn't necessarily have to be on the server that you've backed up from. You click on a button to say connect to an Exchange server, you give it an Exchange server address, you give it credentials to log into that Exchange server. It's equivalent to logging in over an Outlook Web Access connection, and then you can see that live mailbox on that other server, and from then you can then restore directly into any folder that you've got access to. So if you've got a user that says, I've deleted some email, you've found it through the EGR, you can just push it straight back into their inbox. So from a user's point of view, it'll just magically reappear in their inbox, including any folder structure. You can restore it. It's not just individual messages. The final add-on I just want to mention is the SQL Server add-on. Up until now, we've provided methods for backing up a local Exchange server. So if Exchange is running on the machine that Backup Assist is running on, we can back up the Exchange server. Sorry, the SQL server. And we can restore the whole SQL database back to a point in time. But for those more granular requirements of SQL, where you want to actually restore potentially data from an exact point in time, this is really where the SQL Server Protection add-on comes into play. It's the main feature is that it can connect to either a local SQL server or to a remote SQL server. So you can point it to a server on the network, and you can have multiple jobs that connect to different SQL servers if required. So there's no limit to the number of SQL servers or databases you back up. And it brings that data into, well, so I should say, it stores that data back on the Backup Assist server on whatever destination you choose as a standard Microsoft BAK backup file for SQL. I've not shown the screenshot here, but the added ability here is you can run this up to every 5 minutes throughout the day. So if you have a SQL database that is changing a lot, it's got a lot of transactions going on, it's definitely beneficial to keep getting these snapshots every 5 minutes of the changed data. It's the transaction logs it's backing up. So it means that should you ever need to restore a database back to a specific transaction, you can do that through the Backup Assist SQL Restore console. So it adds that more granular backup of SQL on top of your main backups that maybe are just happening once a day. The last couple of things, Backup Assist includes remote administration through a web interface. This is a feature that allows you to effectively manage multiple Backup Assist installations on a local network. You designate one machine to be the master server, and you log into that machine through a web interface, and then from there it can control any other installations itself, but any other installations you may have on the local network. There's no additional software to install or purchase. This is part of the main Backup Assist license. It's really there at the moment in version 7 of Backup Assist. It's there as a LAN-based management tool. In version 8, they're extending this to be a multi-site management tool, so it will allow you to effectively have the ability to control Backup Assist installations across WANs across multiple installations. If you're reselling, you may be thinking about managing multiple customers' deployments of Backup Assist. That's not quite there. That's coming in the next release. Right now, it's a LAN-based tool. To give you a sort of indication of how it looks, it's a web interface. You effectively go into the web interface. You have a log on, a username, and password, and once you're logged into that interface, you can select from any local computers that you've connected to itself, or any other ones you can add and connect to from then on. You can then choose a computer and see all the backup jobs that are running or set up to run on that Backup Assist installation. You can stop jobs, you can monitor them live to see what's actually happening, whether they're running, how long they've been running for. You can get access to all of the reports and drill right down into the report information, all the historic reports. And you can even click through and run a remote console. So effectively you get a copy of Backup Assist running remotely to the server. So from there you can take full control of a Backup Assist and create and edit jobs and do everything else you would do if you were sat in front of Backup Assist. But it's effectively there in this stage as a LAN-based remote management monitoring solution. The other sort of monitoring solution that is built into Backup Assist, or I should say isn't actually part of Backup Assist, is the Central Monitoring Console. Now this actually was the first monitoring tool that they developed, and this is a portal, a web-based portal that you can have access to. You effectively register your Backup Assist installations to push all of their reports back to the Central Monitoring Console, and then as a remote user you can get access to the CMC, the Central Monitoring Console, and see all of these reports. The key function here, I think, is the ability to send a daily summary email out to a predefined address. So if you're managing hundreds of backup assist installations or even tens of backup assist installations, it's still very useful to not have lots of emails coming in every day. You can have one single email that summarizes potentially any servers where backups haven't been fully successful, so you can then immediately drill down into those reports. It's all linked through to the CMC, so you don't have to get access to the remote server. You can just, from the email, click on links and get access to the data that it contains and look at the reports. I should mention as well that the 90 days history is kept, and all of the main function is to consolidate these reports. You should bear in mind that the central monitoring console is actually a free solution for any Backup Assist partners when you've sold 5 or more Backup Assist licenses with upgrade protection. It's something we can link through. It's provided by Backup Assist directly, but like I say, it's free if you're monitoring multiple sites. Personally, I think that the next release of the remote administration service will probably take over the need for the CMC, but we're kind of at a crossover point at the moment. So that kind of brings me to the end of the webinar. But I've got a few minutes now for any questions you may have had. But hopefully that's been useful.